Hello, guys. Today I'm going to talk about the rule of least power. I'm Jason. I'm a software engineer at Test, and I'm a big fan of functional programming, despite not knowing very much about it. And I love Vue, React, and TypeScript, and basically any technologies too. And I'm a Vim user. So the plan for today's talk is that we'll talk about what the rule of least power is and how we can use it in language choices and also in writing code. Before we start, please take this presentation with a pinch of salt because most of the content were just invented by me, and it's just something that I've observed and theorized. So it's not something that is a don't treat this talk as the only source of truth. So it's by no means I mean to define what clean code, or take it with a pinch of salt. Okay, so the rule of least power. The rule of least power was proposed by Tim Berners-Lee, the guy who basically invented the World Wide Web single-handedly. And the rule basically describes how we should choose technologies when solving a problem. So when we have a problem, there are usually many ways to approach it from the technologies that we use. So, for example, if we want to represent some data, we could use JSON, or we could use JavaScript, or we could use Java, or we can use any other languages. So here I have two versions. One is JSON, the other version is JavaScript. And as you can see, they look almost identical. So you might be wondering why we should prefer the less powerful one, the JSON version, instead of the JavaScript version. So to talk about that, we will need to talk about why JavaScript is more powerful language. So I think the power level of a language can be determined by the number of ways that we can express things with it. So going back to the example, in the JSON version, there isn't really many ways to express this data. So this data contains two cars, right? So the first car is a red car, and the second car is a blue car. And in JSON, there isn't many ways that you can represent that, right? The most you can do is swapping the order of the type and color attributes. Otherwise, there isn't much that you can do. However, in JavaScript, there are many ways that you can express the same data. So here are some examples. So maybe we could have a create car factory that takes in the color and create that car object, and then just have an array that calls the create car with the color. These two code represent the same data, but the JSON version, which is the less powerful version, is obviously easier to read, and it is more flexible in many ways. So if imagine you're writing a program to parse these two code, the JSON version will be much easier to parse and analyze, whereas the JavaScript version probably takes more effort into analyzing the semantics of the language itself. You have to understand what is a function, and then you have to do all sort of replacement in order to retrieve the data from the JavaScript version. This is what Tim Berners-Lee meant when he introduced the rule of least power. So this is how he designed the World Wide Web. So in the web, we use HTML, CSS, and JavaScript. The reason is because those are the less powerful languages at the time. HTML is just a simple markup. CSS is just styling sheet. There isn't much that you can do with those, but JavaScript is more powerful. But let's talk about that later. But basically, that is how Tim Berners, the design philosophy behind the World Wide Web. So I think there's another thing that will affect the power level of a language as well, which is the number of things that can sneak into things. What that means is, going back to our example, we have a JSON version of the data and a JavaScript version of the data. So we could sneak some operations into the JavaScript. For example, in here, we put in fetch fruits and fetch videos, whatever they are doing. But there's something that is irrelevant to the data representation, the aim of the code. But then it's irrelevant to the aim of the code, which is to represent the data. But then we have some noise here that is unnecessary. So I think, so to recap, basically, the two ways to define the power level of a language, they're defined by the number of ways that you can express a thing, and also the number of things that you can sneak into the things, if that makes sense. All right. So next, after knowing about this rule of least power, it inspired me to think further, and I was like, what if we apply this even further than just language choices? So Tim Berners-Lee, initially when he proposed the rule of least power, it was only for technologies choices, so technical choices, and I've come to realize that maybe it will work too if we apply the rule of least power in code. So I think rule of least power applies beyond language choices. So here are some examples of how we can use a less powerful code in our code. So I have a love-hate relationship with Vue.js, and I love how powerful it is, but I hate how difficult it is to read it. And even for simple Vue.js like these, it forces me to read into it so that it doesn't have anything tricky in there. That takes me some time to read it. So comparing to, on the left-hand side, just with string methods and operators, it becomes much simpler. The reader do not need to worry about things sneaking into the regex, or the regex doing crazy stuff, because we know that the equal operator will just compare two strings. So it's obvious that the flag equals happy. We just check if they are the same string. Whereas on the right hand side, although it is doing the same thing, it is more difficult. It is harder to read, because we'll need to read into the regex in order to understand what that regex is doing. So in here, obviously, the left column is the less powerful expressions, and that enhances the readability of our code a lot. So let's just quickly go through these. So includes is basically just happy.test, and then start with is basically using the we can so we can use start with, we can use ends with, we can use includes, and we can use to lowercase if we want case insensitive. So you can see how there are already many methods in string that comes with JavaScript that can help us to do these sort of tasks, and we won't need regex for this. So, but of course, matching emails, matching something more sophisticated require regex. But in the cases that I have listed here, we can always choose to use the less powerful version. So here are more examples. So I've seen people writing this xs.reduce and then pass in a comparing reducer, and then with a default value negative infinity. This is basically just math.max spreading excess. So in here, math.max is less powerful because all it can do is to get the maximum value given the arguments. However, the reduce version is more powerful because reduce can do anything. Reduce can literally do anything that a for loop can do. So people will need to take the extra effort reading into what is passed into reduce in order to understand what that whole expression is doing. So in here, clearly, math.max is much more readable, much simpler code, much cleaner choice. So here, more example, merging objects, we can use object assign instead of reducing, or we can use object spread even better than object assign, because object assign will mutate the first object. So when the reader reads the code, they will need to read whether the first object is passed in, otherwise it will get mutated. Whereas in the object spread syntax, we don't have to worry about mutating anything, because we know that spreading will just create a new object that points to that has the properties merge. In the last example here, I deconstruct the Earth from the universe. I consider this as a less powerful statement as well. Statement. It's probably not a statement. I consider this a less. I consider deconstructing as a less powerful feature as well. Because we. So in the last example, we have a function that takes in the Earth, deconstructing the Earth from the universe, and on the right hand side we have a function that takes in the universe. And obviously the left hand side is much simpler, because the reason for it being simpler is because we just take in the Earth, and as a reader, when we read this code, we know that this function is not going to touch anything else other than the Earth in the universe. Whereas on the right hand side, if we read the code, we will see we wouldn't know whether F will mess with other things in the universe apart from outside of the Earth. So yeah, deconstructing help with readability as well. It helps with it. Deconstructing variables is less powerful than getting the whole object in and just use the Earth, if that makes sense. All right. Anyways, moving on. I hope by now you have the idea what I mean when I talk about using the rule of least power in our code. And I hope that you agree that it helps readability. If you do not agree, then go. You can try it out at your own time, and do message me about anything if you think that you found something that is more powerful but it is actually more readable. Do let me know. But next, I would like to talk about depowering. So depowering is a way that I invented to take power away from statements or expressions. So I put it into three types: depowering by abstractions, depowering by conventions, and depowering by types. So depowering by abstraction. So it's basically defining functions. I think every function is depowering things. So for example, in here, we have a sum function that use reduce to sum to add every digit in excess. And by having this function, now when developer put the sum function, the reader do not need to read into reduce in order to understand what is going on, because sum is an obvious function that just add every integer, every number in excess. And here's a min by function that gives you the x that has the minimum n. So this is also abstracting, also depowering these statements. Another very good example is a library called path to regex. So basically you pass in a root, you pass in a root and then you get back a regex that match that root. This is also depowering by abstraction. So you're creating a function that wraps around the power of regex. Next is depowering by convention. So we can establish some convention with the developers, and in the team, we can agree on some rules on how we should use some functions, and by doing that, we can depower the function. By doing that, whenever the reader reads into those functions, we can make use of those assumption, and the code becomes easier to read. So an example would be map, filter, reduce functions. So these functions are very powerful because anything a for loop can do, these functions can also do, because they iterate every object in an array, right? So in order to depower this, in my engineering team, we have agreed to only use map, filter, reduce if we are going to use the value returned by those functions. So by establishing this convention, whenever the reader reads these functions, the reader will be sure that it's not doing anything other than just mapping, filtering, and reducing, and this helps the readability. Last, I'd like to talk about how we can also depower things with types. So we can depower things with type if we have, for example, if we just use interface, if we just use an interface with a few properties. This way, it's similar to destructuring. We take in less values from the type. If you want to learn more about this, you can go to my article on dev.to to read more about this. And yeah, this summarized my whole presentation. I hope you enjoyed this presentation, and yeah, see you next time.